Hello everyone, welcome back to 8th session of this IoT course. Last session I have demonstrated how to download Arduino IDE in your computer or laptop and how you can write a code in Arduino IDE. Also I have demonstrated a project that is blinking LED. At the end of this session, today I will demonstrate two projects. One is temperature control of a room using temperature sensor. Another one is car parking system using ultrasound sensor. Okay. Problem statement. Temperature and humidity control is extremely important in modern industries, especially food industries, laboratory, pharmaceutical industries. Food safety law states that all food products have to be kept at designated temperature if they are going to be safe to eat. Having them too cold renders them inedible, and too warm and it could encourage bacterial growth. So it is essential to have a temperature monitor to protect the health of consumers. We know excess humidity causes problems such as corrosion and IT equipment failure. Moreover, dryness of the skin directly affects several metabolic functions, including oxygen intake, the shedding of water vapor, salts, heat, etc. So it is very important to keep track of the temperature and humidity not only in offices and labs but also in our home. In this module, we look forward to implement a cheap and effective solution to this problem using a microcontroller, that is Arduino. So I will demonstrate this particular project by using Arduino IDE and Arduino board and the DHT11 sensor. Hardware and software requirements. Hardware requirements. One Arduino Uno R3 board, one USB cable type B, DHT11 sensor, one buzzer, connecting events, breadboard, and recommended software Arduino IDE. DHT11 sensor. DHT11 sensor is one of the most common temperature and humidity sensor. DHT11 sensors comes as sensor or a module. The sensor has 4 pins, whereas module has 3 pins. The module has inbuilt filtering capacitor and resistor for the sensor. The sensor can measure temperature from 0 degree to 50 degree centigrade and humidity from 20% to 85% with the accuracy of plus minus 1 degree centigrade for temperature and plus minus 1% for humidity. Guys, you can see the DHT11 sensor picture. The left one is module and the right one is the sensor. So you have 3 pins in module. One is the data and there is the VCC, is 5 volt, that is plus, and the ground means minus. The middle one is the data pin. The right side we have the sensor which has also VCC, data and ground. This is the circuit diagram. Guys, you can see this is the DHT11 sensor. So we are required to connect the Arduino in following manner. Already I told you. The VCC pin goes to 5 volt, the ground pin goes to the ground pin. Connection from data pin goes to digital pin 7, already I told you. Buzzer positive is connected to digital pin 2. Buzzer negative pin is connected to register to the ground pin. Register to the ground pin. Now let's look at the real components. This is Arduino Uno board, or you can say this is a microcontroller board, and this is the microcontroller Atmega 328, which has 8-bit microprocessor. This is the microcontroller. This is the microcontroller. Already I told you what is microcontroller. Microcontroller means whenever you have on-chip microprocessor, that is CPU, memory and input-output peripherals, or you can say programmable input-output peripherals or pins, then it is called microcontroller. This is the microcontroller. This is Atmega 328 chip, the microcontroller chip. Here you have a microprocessor, you can say 8-bit microprocessor in Atmega 328 chip, 8-bit microprocessor. So now it has also static RAM, EEPROM and the flash memory where you upload the program. So you can see over here there are 14 digital pins, or you can say ports. Among these 14 digital pins, 2 are transmitter and receiver pin. That is, pin number 0 is receiver pin and pin number 1 is transmitter pin. Among 14 pins, 6 pins are PWM pin, pulse width modulation pin, where input is digital but output is variable analog voltage. Okay. After that, I think you can see guys, 0 to 13 are digital pin. Now after that we have one ground pin, and then after that we have AREF pin, and rest are unused. So now over here we have 6 analog pins guys, you can see from A0 to A5. After that we have one VIN pin, then ground pins, then 5 volt pin, then 3.3 volt pin, one reset pin and one IO reference pin. Okay, this is all about the pin, or you can say ports. So now here you can see guys, the red one, this red button, this is basically the reset pin. You can reset the circuit pressing on this particular pin. This is the crystal. These are the condensers. Here you have many resistors within this board. The board itself is called the printed circuit board. The blue board is called printed circuit board, called PCB. This is the port through which you can connect the USB cable, right? And you can connect to your laptop or computer for uploading program or transferring data. This is crystal. This is the port where you can connect the external power supply or battery. Okay guys. So I'll tell you one thing, that this input output ports, that is the IO peripherals or pins you can say of this microcontroller chip, can communicate all these pins, like the digital pins, analog pins and all other pins over here. Okay, so this circuit is actually fabricated within this board internally. Okay, so that is the basic understanding of what is Arduino board. This is a DHT11 sensor which has 3 pins. Minus is ground, then the middle one is the data pin, and this is plus means VCC or 5 volt. This is buzzer which has 2 pins, or you can say wires. Okay, here, so the black one is the ground and the red one is the VCC or positive. You can say this is black one is negative and this is the positive. So now I will assemble these components for doing the project temperature and humidity monitoring for a room. So now I will connect as per the circuit diagram, but I will tell you in circuit diagram I have used one breadboard and one resistance. So I have used resistance to connect the buzzer, but for simplicity I will connect buzzer directly to the port rather through resistance. So now I will connect this -1, that is ground pin, to GND. You can say, guys, this is GND pin. Now I will connect the positive pin to VCC, that is 5 volt. Now I will connect the data pin in pin number 7, digital pin number 7, as per the circuit diagram. I will connect now this component buzzer, the negative pin to ground, and the positive pin to pin number 2. That is the circuit. Point to be noted that in circuit diagram I have used one breadboard and one resistance to connect buzzer, but here for simplicity I have connected the buzzer directly to ground pin and the positive pin. Now I will connect USB cable to this Arduino board and to my laptop. So now I will install library. We need to import certain libraries for the sensor to work. Already I told you. So open the Arduino IDE and go to Sketch, include library and manage library. So now guys, here you can search, you can see the screen. This is a search option. You can just click on search. Already I have discussed this thing earlier. So search DHT and install DHT library from AdaFruit. After installing DHT library, we also need to install the AdaFruit unified sensor. Search for AdaFruit unified sensor and install the library. As you can see the screen, in a search box, in this search box DHT is written, and this is the DHT sensor library you have to install. Now we'll come to the code. So you have to include the DHT library, right? So that's why I have written include DHT.h. Small DHT, capital DHT means creates an instance DHT of DHT. So here we have the read function, read the value from DHT11 pin and updates the instance capital DHT. Then you can print the value by using serial.print temperature and humidity. You can see guys, just serial println DHT, it is capital DHT instance dot temperature, capital DHT is instance of DHT dot humidity. And here I wrote if the DHT humidity greater than equals to 90 and the temperature greater than equals to 30, then the buzzer will start ringing and it will print like this abnormal rise in temperature or humidity. So we also have inserted some relay functions for 2000 milliseconds. So now you can see copy the code on onto the Arduino file and compile the code using Control R, or go to Sketch, verify or compile, or you can just click on upload. Connect the Arduino board to the computer. If the code is compiled without errors, upload the code to Arduino board using Ctrl+U, or go to Sketch and then upload. Go to Tools, Serial Monitor to check the output. This is the serial monitor, you can see guys. I will show you. Press enter. You can now see the reading of the sensor in serial monitor. Okay, so that is the steps you have to follow. So now I'll go to Arduino IDE. I'll go to Arduino IDE. Already code is written over here. So I have written this thing. You can check. Only things what I did, that I have changed the temperature to 30 to 20, or you can also write this one, because to check the whether buzzer is ringing or not, or you can change it to 30 also, doesn't matter. Already I told you, you can click on verify or compile, right? So, but I want to do both together, is compilation and upload. That's why I am clicking this. But before clicking this, go to Tool, select the board. This is board is Arduino Uno. Then I'll go to port. Port is COM3. Select it, and then upload. Compile and upload. This is the compile and upload options. What you can do, you can just first compile, then upload also. But it's better to click this one. That means you can compile as well as you can upload the code in Arduino board or Arduino flash memory. So I think uploading done. Just you can go to serial monitor from the tool. This is serial monitor. Guys, you can see the temperature and the humidity, also the alarm, and you can also hear the buzzer sound, right? We can also replace this buzzer by LED also if you want. If you don't have buzzer, then you can use LED in place of buzzer. You can see the temperature and the humidity, right? And the alarm message also, because the temperature is now 25 degree of my room. Now I will start second project, that is automated parking system using ultrasonic module. Problem statement. A normal parking system requires a lot of human intervention, as you know. A human has to decide when to open or close the gates, when no to let more cars in because the parking space is full. Now a microcontroller or a system of microcontrollers can do the same amount of job with equal or more effectiveness. This approach cannot solve problems for a huge population or to maximize the efficiency of space available. Modern industries have come a long way in solving such problems. In this module, we will use an ultrasonic sensor to measure the distance of the approaching cars. Hardware and software requirements. Hardware requirements. We need one Arduino Uno R3 board, one USB cable of type B, one SR04 ultrasonic module, one LED, and few connecting wires, or you can say jumpers wire. Recommended software Arduino IDE. You have to download it. Now I will come to specification of SR04 ultrasonic module. You can see from the picture there are 4 pins in AC SR04. Number 1 pin is VCC, number 2 is trigger, number 3 is echo, and number 4 is ground. VCC should be connected to 5 volt. Trigger will generate the pulse, echo will receive the pulse, and ground should be connected to ground port of the Arduino. Now features of ACSR04 module: operating voltage plus 5 volt, theoretical measuring distance 2 cm to 450 cm, practical measuring distance 2 cm to 80 cm, accuracy 3 mm, measuring angle covered less than 15 degree, operating current less than 15 milliampere, operating frequency 40 Hz. Now I will come to working of the ultrasonic sensor. Ultrasonic sensors work by emitting sound waves at a frequency too high for humans to hear. They then wait for the sound to be reflected back, calculating distance based on the time required. This is similar to how radar measures the time it takes a radio wave to return after hitting an object. If you need to measure the specific distance from your sensor, this can be calculated based on this formula: distance equal to half t into v, t equal to time, and v the speed of sound. Now you can see the picture of the working. The trigger pin is generating the sound wave, or you can say wave or pulse. Echo pin is receiving the pulse, and we have to calculate the duration, and the duration is converted into the distance. You can say sonar sensor. This is called sonar. This is the circuit diagram. We are required to connect the Arduino in the following manner. The VCC pin goes to 5 volt, the ground pin goes to the ground point, connection from trigger pin goes to the digital pin 3, connection from echo pin goes to the digital pin 4. The LED is placed in the digital pin 13. I want to say one thing. So when we will implement it, so we will connect trigger pin in pin number 9 and echo pin in pin number 10. This is Arduino Uno board, which has Atmega 328 chip, which is a microcontroller, where 8-bit microprocessor is there. This is the microcontroller. This is the microcontroller. Already I told you what is microcontroller. Microcontroller means whenever you have on chip microprocessor, that is CPU, memory and input output peripherals, or you can say programmable input output peripherals or pins, then it is called microcontroller. This is the microcontroller. This is Atmega 328 chip, the microcontroller chip. Here you have a microprocessor, you can say 8-bit microprocessor in Atmega 328 chip, 8-bit microprocessor. So now it has also static RAM, EEPROM and the flash memory where you upload the program. So you can see over here there are 14 digital pins, or you can say ports. Among these 14 digital pins, two are transmitter and receiver pin. That is, pin number 0 is receiver pin and pin number 1 is transmitter pin. Among 14 pins, 6 pins are PWM pin, pulse width modulation pin, where input is digital but output is variable analog voltage. Okay. After that, I think you can see, guys, 0 to 13 are digital pin. Now after that we have one ground pin, and then after that we have AREF pin, and rest are unused. So now over here we have 6 analog pins, guys, you can see, from A0 to A5. After that we have one V-in pin, then ground pins, then 5 volt pin, then 3.3 volt pin, one reset pin, and one IO reference pin. Okay, this is all about the pin, or you can say ports. So now here you can see, guys, the red one, the red button. This is basically the reset pin. You can reset the circuit pressing on this particular pin. This is the crystal. These are the condensers. Here you have many resistors within this board. The board itself is called the printed circuit board. The blue board is called printed circuit board, called PCB. This is the port through which you can connect the USB cable, right? And you can connect to your laptop or computer for uploading program or transferring data. This is crystal. This is the port where you can connect the external power supply or battery. Okay, guys. So I'll tell you one thing, that this input output ports, that is the IO peripherals or pins, you can say, of this microcontroller chip, can communicate all these pins, like the digital pins, analog pins, and all other pins over here. Okay, so this circuit is actually fabricated within this board internally. Okay, so that is the basic understanding of what is Arduino board. Now this is ultrasound sensor, which has 4 pins. The first one, the white one, is VCC. The gray one is basically the trigger pin, and the red one is basically the echo pin, and the orange one is basically the ground pin. Trigger pin will generate the pulse and echo will receive the pulse. That means trigger will generate the pulse or signal that will bounce back, and then echo will receive it, and we will find the duration of that, and then we will convert into corresponding distance. This is LED, light emitting diode, which has 2 pins. The larger one is called positive and the smaller one is called negative. Now I will assemble the circuit. In circuit diagram, trigger pin is 9, pin number 9, and echo pin is pin number 10. Okay, so first I will connect VCC to 5 volt. And ground, this is ground, orange is ground, to ground pin. Now I'll connect trigger pin to pin number 9, and echo pin to pin number 10. This is the circuit. Now I'll connect LED to pin number, the positive pin to pin number 13, and the negative to ground. That's it, guys. This is all about the circuit for car parking system. Now I'll connect USB cable to Arduino port, and other one I'll connect to my laptop. This is the code for the project. Here the trigger pin is 3 and echo pin is 2, but when we will actually implement it, we will connect trigger pin in 9 and echo pin in pin number 10. LED pins remain unchanged, there is 13. So we will take one variable called distance, integer type, and another long type is duration. So set it trigger pin as output pin and echo pin also input pin. Pin mode LED pin as output pin, and also initialize the baud rate as 9600. So now the logic. So first we will initialize the trigger pin to low for 2 microseconds, and then set trigger pin as high for 10 microseconds, and once again set the trigger pin as low, right, and then the echo pin will receive the pulse and calculate the duration, and then duration is converted to the distance according to the standard formula. So now if the distance is less than 10 centimeter, so gate will open and just LED will glow. Okay, guys, and we have inserted one delay of 2000 millisecond to pass. So this is the output, that is the serial monitor. You can see, guys, you can see the distance and also the message open the gate if the distance is less than 10 centimeter. What you have to do, copy the code on to the Arduino file and compile the code using Ctrl+R or go to sketch, then verify or compile. Connect the Arduino board to the computer. If the code is compiled without error, upload the code to the Arduino board using Ctrl+U or go to sketch, then upload. But I will recommend to just click on upload directly for both the functionalities like compile and upload. Go to tools, then serial monitor, or you can press Ctrl+Shift+M to get the serial monitor. Then press enter. You can now see the reading of the sensor in the serial monitor. Guys, you can see the distance in serial monitor. Also keep a look on the LED when the objects are close to the sensor. So now I will go to Arduino IDE. Already code is written over here, so I have written this thing. Before uploading, go to tools, select the board, Arduino Uno already selected. Still I am selecting once again tools, select the port is COM4 already selected, but I am selecting once again and then upload. Already I told you, you can click on verify or compile, right? So but I want to do both together, is compilation and upload, that's why I am clicking this. Now I will upload the code. Click on upload option, that means compile and upload. Compilation is going on. compilation is over, uploading is over. Now I'll open serial monitor, guys. You can see the distance. Okay, so now I will move the car towards ultrasound sensor. Guys, you can see distance is decreasing, and also you can see the message gate is open. So that means you can see also the LED is glowing. So now I will move the car back. Guys, you can see distance is increasing and there is no message for gate open. That's it for today. Thank you very much.